All right, so this problem is an essential standard where it's asking you to show whether or not this figure is a parallelogram. Now, remember, when it says show if it's parallelogram, you can't just say, oh yeah, slopes, or oh yeah, stuff is congruent. You really have to show it by either using slope formula or distance formula, whichever one you feel that you're best at. I am going to go ahead and show you using slope formula because personally, I think it's a little bit easier for me to do. But I'm going to show you all the steps that you need to show in order for you to have the appropriate work. Okay, so if I'm going by the slopes route in my work, I'm going to write down, hey, I'm going to find the slopes, but I will first find the slope of the opposite side. So I'll find the slope of AB first, and then I'll find the slope of DC next, because I want those two slopes to show to be the same. So if I'm going to find the slope of AB, you can either do rise over run, or you can use the slope formula. I'm going to tell you a lot of people who use rise over run tend to mess up the rise over run. So I'm going to show you using the slope formula just to get you to see both ways. So if I choose x1, y1 to be that point, x2, y2, I'm just going to substitute the values in. So I'll have 2 minus 3 over 3 minus negative 2. 2 minus 3 gives me negative 1. 3 minus negative 2 gives me negative 1/5. So that's one way to approach finding your slopes. If you want to do it that way, it's just using the formula. The other way would be to use rise over run. Again, a lot of people tend to mess this up, but I'm going to show you the appropriate way to do it on here. So you will start with the leftmost point and you will get to the rightmost point and just kind of show what I have to do to get there. So rise, technically I'm falling actually, and then I'm going to count how many units it goes this way. So if I fall from D, that's going to make it a negative. So you're going down 1 and to the right, 1, 2, 3, 4, it looks like 5. So if I'm going to do rise over run, I have to remember that if I go down, I'm going to have a negative, or if I go left, I'm going to have a negative, but I will get negative 1 over 5, and that's the same slope as segment AB. So your first conclusion you're going to make is, all right, these two slopes were the same, but what does that actually do for you? That actually shows you that AB and DC are parallel to each other. I repeat, parallel, not congruent, parallel, okay? Just because the slopes are the same doesn't mean that you have showed that they are the segments are congruent. It only shows that the segments are parallel to each other. So that's my first, I call it a semi-conclusion, okay? Then the next one is, that's not enough to prove that it's a parallelogram, unfortunately. That only proved this guy parallel to this one. So you will continue and you will find the slope of segment AD and the slope of segment BC. I'm going to use rise over run just because it's a little bit faster. But again, if you want to go back to finding your slopes using the slope formula, you are welcome to do that as well. Either way is fine. So let me go back and let's start with segment AD. So I'm going to start with the leftmost point. So now my rise is up this much and right this much. So let's see, 1, 2, 3 is my rise, and my run looks like I'm running 1. So if I do rise over run for this one, because I'm going to up, I'm going to say up 3 is going to give me a positive. I went to the right one, which is actually still positive. So you get a slope of 3 for this one. For segment BC, again, start with the leftmost point, go up however much, right however much. So it's 1, 2. That one is also a rise over rise of 3 and a run of 1. So I end up getting 3 over 1 for this one as well, which reduces to be the number 3. Again, what does that tell you? Just writing this down doesn't give me anything. It doesn't help me understand your conclusions about like what has actually happened. So your conclusion now should be, okay, they have the same slope. Again, I repeat, that does not mean that you have proved the segments to be congruent. It only helps you prove that the segments are parallel. So why does that help? Well, you proved both pairs of opposite sides to be parallel, my friends. So that makes this to be a parallelogram. That's actually the definition of a parallelogram, but this last statement that says, which property did you use to prove your answer above? You're going to have to pick one of those 6 properties of a parallelogram. So let me remind you what those 6 properties are. There they are. Both pairs of opposite sides parallel, both pairs of opposite sides congruent. All of these are properties of a parallelogram. The only ones you can really show on a coordinate plane for these types of problems are the first and the second, possibly this 5th one, and possibly the 6th one, but usually I go with the first one. So I'm going to say both pairs of opposite sides are parallel. And really, if you're going to say this, that both pairs of opposite sides are parallel, you have to make sure somewhere in your proof up here, you've actually shown why they are parallel. See how I have one pair of sides parallel here, another pair of sides parallel here, and also the evidence from my slopes to show you that. Just seeing these numbers over here on the diagram doesn't show me enough. It doesn't help me understand why you have the slopes being the same and then what that actually tells you from there. So kind of take a nice gander at this, because this would be the appropriate way to answer, or one of the appropriate ways to answer this question.